Good morning. Welcome to the session Evading Active Directory, Evading Microsoft ADA for Active Directory Domination. I am Nikhil Mittal, speaker for this talk. Before we begin, a couple of things about me. I'm a red teamer, hacker. I speak a lot at conferences, train at conferences. I'm with pentesteracademy.com. You can find me on Twitter as Nikhil_MITT, so please go follow me. I blog on labofApenetration_tester.com, which is my home on the interwebs. All my ongoing projects, works, research, whatever, I like to blog about it there. I maintain 2 open source toolkits on GitHub. You can find me as Samrat Ashok on GitHub, Kautilya and Nishang. Kautilya is a toolkit which you can use to create ready-to-use sketches for Arduino-based devices. You burn it to an Arduino device, plug it into a box, and it will do interesting stuff for you. And Nishang there are more users of Nishang. It's a framework or a collection of PowerShell scripts which you can use in various phases of penetration tests. All right. I'm generally interested in different ways of breaking into the machines where, of course, I have the permission to do so. And if there are defense tools which come in my way while doing that, I would generally like to find bypasses. I've previously spoken at DEF CON, Black Hat multiple times, trained at CancerQuest and a few more conferences. So what we are going to discuss here is, we'll start with what ATA is, what is the architecture, if there are some of you who have not seen it or do not know about it. We'll quickly go through it. What are the detections? What are the kind of attacks which ATA detects? What are the alerts? How they are managed, etc. Then we'll move on and see how we can, as a good attacker, how it is possible to bypass ATA headline attacks and useful ones as well, like overpass the hash, golden tickets, etc. How is it possible to use them and still not get detected? Then we'll move on, see how we can modify our attack chains or penetration testing methodology or whatever you want to call it to simply avoid talking to the domain controller and thus ATA. Then we'll have a look at a couple of attack chains or methodologies, which assuming that domain administration, domain admin privileges are the goal. And so domain dominance, that is, once you have domain admin privileges, you can clearly have a domination over a domain. Then next comes attacking ATA. Once we have enough privileges, is it possible to attack ATA in some sense or some method? Then we'll conclude with that. So what is Microsoft ATA? So I'll read out the definition. Advanced Threat Analytics ATA is an on-premises platform that helps protect your enterprise from multiple types of advanced targeted cyber attacks and insider threats. Pretty common vendor definition. So how ATA works is, whatever is the traffic being sent to your domain controller, one of the domain controllers or all of them, depends on the type of implementation you want. It reads certain protocols. What protocols? Like Kerberos, DNS, LDAP, SMB, etc. This tool or the sensors of this tool reads those protocols and then try to detect an attacker in 2 ways: anomaly and user behavior, UBA. So in this talk, we are going to focus on the anomaly-based attacks, which attack on day 1. ATA has, I think, 21 days of learning period before it can start. In this 21 days period, it builds a profile of each and every user and box, and then it can actually detect UBA or behavior detection. But the anomaly detection starts from day 1, and that is something which we are going to focus on the talk. The lab configuration which I have used and which I will be going to use for the live demonstrations. So I worked on ATA 1.7, then 1.8 came out like last month. tested interesting things on that as well. The ATA sensors for installation in my environment, it has been used in my classes as well. So more than 400 attackers, students have tested their hands-on. So one thing I can guarantee you that the bypasses which we have a look at here have been thoroughly tested. I am using, so there are two ways of implementation of ATA. I'm using a lightweight gateway, that is the sensor is living onto the domain controller. It's not a separate box. So that doesn't make any difference to the detection as far as I know, but just wanted to let that out. So the threats of interest which ATA detects, it detects so many things. So for my particular methodology, I always saw these detections if I'm not trying to bypass it, or in the initial days when I found out what ATA is and how it detects things. These are some of the attacks which it detects. So in recon phase, account enumeration, if you would like to get interesting data from the domain, like list of computers, member computers, users, interesting group memberships like domain admins, enterprise admins, etc. Then compromised credentials, brute force attacks, unusual protocol implementation, we'll see what this is, abnormal behavior. So for me, once again, we are not going to focus on abnormal behavior detections here, but that's something which interested me initially. Then in the lateral movement phase, and this is where ATA really kicks in, attacks like golden ticket, overpass the hash, reuse of tokens, remote code execution attempts onto the domain controller, and of course, domain dominance. So yeah, golden ticket comes over here, and malicious replications request, the famous DC sync attack. So all of this has been taken from the Microsoft's documentation. Now let's quickly jump in and see how an attacker gets detected. So this is an example. If you run any tool like NetView or PowerView or even the simple net commands, let's say you run net group domain admin /domain, this is something which your ATA console will show you. Recon using directory services enumeration or recon using SMB session enumeration with a medium severity, which is fine. I mean, getting your recon detected is fine as long as you are not dealing with an organization which takes its security really seriously. Later on, when we'll have a look at the console, you will see that not only this is detected, or let me show you that right away. This is how it looks like onto the ATA console. So if I have an SMB session enumeration right here, so you can not only see that it was done against the domain controller, but from the box, from the user. So that makes, when I first encountered ATA, this is the thing which worried me. Your session enumeration getting detected or raising a couple of flags which gets marked as resolved is fine. But this tool can pinpoint on a particular box and user, which was scary for me at the very first time. Then slowly, once you start playing with ATA, you get to understand how it detects things. For example, in case of any recon, ATA generally, at least up to 1.7, ATA does not really mind DC giving out the information. That is, if you ask, give me the list of computers, it's fine. Give me the membership of domain admins group, that's fine as well, as long as then you do not go back to the DC and do some intrusive enumeration. And now that's what's that intrusive enumeration? We'll come back to that in a moment. So if you do not use, we are going to use PowerView here in this demo which I have ready for you. If you are not using your tools blindly and know what they do, it is not really hard to bypass ATA. So not poking the DC, once again, not poking the DC is the key. Understand this, ATA looks at all the traffic which goes to the DC, some protocols which goes to the DC. So as long as you're talking to the DC in a really normal way, normal conversation, or avoiding it at all, you won't be detected. So let's have a look at the example of hunting for domain admin token, also called user hunting, a very, very popular method with red teamers. So in PowerView, you use invoke user hunter for this. What this hunting means, you go to the domain controller, ask for two things. First, give me a list of all the boxes. Second, give me the list of the domain admins. Then it goes to each and every box and asks for two things. Give me the current sessions and current logons. And then the tool matches if current session or current logon users has membership of the domain admins, which it has. That's how user hunting works. So the way to bypass it is this. When you run, and I'm taking PowerView just as an example because I work a lot on PowerShell and that's an awesome tool. If you request a list of machines from a domain controller before running PowerView blindly on that, because when you run invoke user hunter, once again it automatically fetches the list of all boxes and runs enumeration on them. Make sure that you do not run that user hunting specifically onto the domain controller. That's it. If you do that, and if I would like to show a demonstration of that in a moment, if you do that, that doesn't get detected. Retrieve the information from the DC like computer names and domain admin membership, but do not retrieve information like current logged on users or current sessions, and you will be good. Another interesting recon mechanism which ATA can't catch is SPN scanning. So those of you who are not aware, so a service principal name is used by Kerberos to keep track of service accounts in an Active Directory environment, to put it the easy way. If you do SPN scanning, once again for which you can use individual scripts or PowerView, that doesn't get detected as well. So let's have a look at how we can actually use PowerView and still evade detection. So we have ATA 1.8 here. So there has been no detection up to now. Now what I do here, this machine 11.2, and please don't deauth me from the Wi-Fi. What this machine has, it's a part of the domain. The user is not any special user. I don't think not even a local admin on the box, or if it is, that's the max privileges it has. It's a normal domain user. So what we can do with these privileges, is this visible till the back, the PowerShell session? Yes, thanks. So, and I'm not going to do any recorded demos, so let's see how it goes. Let's load PowerView here. I think I used a comma. Now, not using invoke user hunter directly, what we can do is something like this. So we get a list of all the boxes in this domain, right? Next thing which we can run is this, which is not required, although we can leave this part to invoke user hunter. But just in case, let's see. What are the different domain admins? Okay. So there are two domain admins. So what we would have done, or what many of us red teamers are guilty of doing, is something like this. After these obligatory domain enumeration things, what we do is simply something like this, invoke user hunter. And then we wait, invoke user hunter or PowerView does its magic, then we try to target that box where a domain admin is logged in, which is almost correct. Just have a look at the list returned by the DC. It lists itself as well, right? So the only modification you need to do here is save this list to a file. Let's say this. Oh, the font is really small. Something like this. Even if this is not visible, what we have changed here is the first box. That is, let's just not run user hunting onto the DC. What we'll do in place of that is this. We are going to use the computer file option which comes with PowerView. Pass a list of computers. And now if you see, it doesn't go to the DC to get a list of the boxes because we have provided that. And now it goes to each and every box and looks for if there is a box where a domain admin is logged in. And that is it. ATA won't detect it. Why? Because you have not executed the intrusive enumeration against the domain controller. Just very normal things. You know, getting a list of boxes, it's almost this thing. So that's what we did when we ran getnet computer. That's how you avoid recon. And is this powerful? Really, you can use this against any sort of enumeration. If you are going to have a look for local admin access on all the boxes, use computer file parameter. Just avoid the intrusive one for the DC. That's the trick. Now brute force. How many of you actually use brute forcing in Active Directory environments? Come on. Is there no one who uses brute force attacks in Active Directory? Yeah, one of you? Wow. So of course you should use brute force in Active Directory environments. Just use a modified version. Use a single password and try it across the boxes. You know, there is no password policy in the world in production, and there won't be any which locks a user account on a single wrong attempt, right? And that's a well-known trick, really well-known one. So if we do this, there's no detection as well. So how a normal one gets detected? It gets detected like this. So that's a normal brute force when you try multiple passwords against a user. XSS number of authentication failures 507 within few seconds. So if you actually work with ATA and try to see how it detects things, once again it's not really hard to get around it. So if we go here, the next thing which we are going to use is invoke brute force, a script which is part of the Nishank toolkit. Let's run it. So a small directory or dictionary, sorry, not directory, a small dictionary, just 500 or some passwords. It's the same one which was used when there was detection. What we did, we tried a single password across the Active Directory, single password for each user. That's a well-known technique, doesn't get detected. And now once we are through the enumeration part, the next one, or where the actual meat is, the lateral movement part. So what we have done, the demonstrations are not really connected for a reason which we'll get to know later on. We started with enumeration, found out that domain admin is logged into a box. Then we brute forced, let's say, a domain user which is a local admin on that particular box, right? That makes sense. Now, once we are local administrator on that box where the domain admin token is available, we can, let's say we got our hands on to the credentials of the domain admin. By credentials, I mean its secrets, NTLM hash, AES keys. What overpass the hash attack is, you can create valid Kerberos tickets from NTLM hash or OES keys. So Benjamin, the guy who wrote Mimikatz, has a detailed blog post about this. You can have a look at it. Now, when you create a session with the domain controller, that is, you establish a connection, you want access to a resource. When you request a TGT, asterisk is the packet which gets sent, and I don't know if that's visible or not, but this is how it looks like when it is normal, E-type. So in the pre-auth data, there is a field called E-type, which is AES 256 CTS HMAC SHA1 something, which is the normal one. This is something which you got to have a look at when you're using clear text passwords. But as soon as you use NTLM hash for creating an overpass the hash attack or creating a Kerberos ticket, and then you request a TGT from the KDC or the domain controller or the key distribution center, that's one and the same thing, then you get to see this. The E-type is downgraded to ARC4 HMAC MD5, and that's what, and this is the command which most of us use, right? The username, the domain, and the NTLM hash. This is what ATA detects. Exactly this is the type of anomalies which it is looking for, lazy attackers. So, and there are two detections basically. One, encryption downgrade activity. And once again, if you look closely, ATA tells you how it caught you pants down. AS required. So what does it read? The encryption method of the encrypted timestamp field of AS request message was downgraded. I mean, there can't be anything clearer than that telling you in your face that try to improve your techniques, do not rely on tools blindly. And there is another detection, unusual protocol implementation, which actually it was not possible for me to zero in on the reason of detection. What my wild guess was this. If you look for supported encryption types, in the normal one, these 6 items are there. In the NTLM one, there are these 7 items. And in the AES one, once again, quite similar to the normal one, not the exact ones. So it could be that as well. But if you use AES keys, you might have guessed what happens. If you use AES 128 or AES 256 in place of the NTLM hash, there is no detection. Once again, Benjamin says here, and that's what I have tested, AES keys can only be replaced on 8. That is, you can use AES keys either on 8.1, 10, or 2012 R2, or you need to have this specific patch on the boxes, which actually doesn't make this attack any harder. So if your overpass the hash attack gets detected, use AES keys. And how does that look like? So let me show you that from a 2012 R2 box. Let's see if I have Mimikatz here. So in place of NTLM hash, you're using all the 3 secrets here, AES 256, AES 128, and NTLM hash as well. So we got our, so you can see that here. Compare this with when you run Mimikatz just with the NTLM hash. All these fields are null in those cases, which they are not right now. So if I try to access any resource onto the domain controller right now, I can do that. That means if you have secrets of the Kirby TGT account, not only the NTLM hash, sorry, that comes later on. Right now we are on the domain admin. If you have hashes of a domain administrator, there's no need to use NTLM hash. Go for AES keys, and you would be fine. there would be any detection. So if we go here, there has been no detection. How it gets detected, it's something like this or this. So that's your overpass the hash detection, which ATA actually tells you in your face that I caught your overpass the hash, right? So once you have your overpass the hash attack, you can also do some, once you start reading how it detected, there are some interesting things you can do. For example, you can create fake events, use whatever username in this command here. And that's without AES. So you want it to get detected, but with someone else's username, your colleague who got promoted, but you were not. Something like that. Just kidding. Anything. If you want just to distract defenders or for some other reason, if you would like to create false detections, you can use this. Run normal overpass the hash attack, but in the /user option of Mimikatz, if you're using Mimikatz for that, use whatever username you want. Make sure that you use a correct one so that it gets detected. Also, if you use a non-existent one, you can see here, it still gets detected, but the username field is unknown. So maybe just to create panic or create distraction, you can use this. Also, you can see that if you know, of course, that needs a little bit of work in itself. ATA supports creating honey users or honey tokens. You just create a user in your domain and tell ATA that this is a honey token or a breadcrumb or a deception user. You can create alerts for that user as well. Whatever user, any user in the domain. Now, once you have domain admin privileges, the next step for domain dominance is to have a persistence there. And it would be amazing if that persistence comes with domain admin privileges. That's what we are going to do now. Let's create a golden ticket attack. So those of you who are not aware of it, a golden ticket attack allows you to come back anytime later on. Once you have DA access, pull the Kirby TGT accounts hash, come back later on after maybe let's say 6 months, create a valid TGT and access any resource as the domain admin. That's what a golden ticket attack is. So it was discussed by Skip Duckwall and Benjamin a couple of years back at Black Hat. Now, because it's a valid TGT, the action now moves to the TGS rig packet, and it looks like this. A normal one. This is how a normal golden ticket. And one thing which I would like to emphasize is golden ticket's persistence is based on non-changing Kirby TGT password. So that's the trust anchor point. If the Kirby TGT password is rolled a couple of times, then your golden ticket attack will fail. So with that, this is how a normal TGS rig packet looks like. In the same way we did for overpass the hash attack. If we go here and see the E-type in the TGS rig packet, it's AES 256, CTS, HMAC, SHA1. Now this is how it looks like if you use the NTLM hash of the Kirby TGT account. Clearly a downgrade, and that is what exactly ATA is looking for. So this is the command which we generally use for creating a golden ticket. Whatever username, domain, seed of the domain, and the NTLM hash of the Kirby TGT account. That's what we use normally, right? So this is clearly an anomaly, and it gets detected as encryption downgrade activity. Once again, if you open up the encryption downgrade activity here, let me have a look if this thing. So this is an older one, OPS user 11, a golden ticket has been detected. Why? Because the TGT field of TGS rig message has been downgraded based on previously learned behavior. fair enough. So let's make it normal. And how do we do it? No points for guessing. Once again, using AES keys. And because this time we are not sending the user's keys, we can simply run it from whatever box we want. There's no need to run it from a 2012 R2 box or have a specific patch over there. So let's see. Can we access any resource onto the domain controller right now? No, we can't. Let's create a, nope, not this one. Let's quickly create a golden ticket and see. So do we have Mimikatz here? So we are using AES 256 for the Kirby TGT account here. And can we access a resource now onto the domain controller? Yes, of course we can. I mean, now we have a golden ticket. We can pretty much access any resource in the entire domain. And there's no detection of this. So this one which you see is from yesterday when I was testing things. So you normalize your traffic and there would be no detection. That's the key. So once again, ATA detects golden ticket, use AES keys. So I was quite happy with the, I would like to say this, and I have a slide for that. I worked with the ATA team, it was fantastic. But up to this time, it was very good with ATM, and I was respecting whatever it was doing. But for some strange reason, this happened. You know, if you create a golden ticket with NTLM hash, but you use the username as something which is not in the domain, you make something up, that thing doesn't get detected. And that is something which is really bad. So how does this work? In the command you use, the usual one, you simply use something like this. And this is very interesting, because in my class I had questions like, if we cannot retrieve the AES keys somehow, because the DC sync is one of the best methods, given I have to give this to ATA, no matter from where you run DC sync from the same domain, at least for me, I couldn't find any way to not get detected. So this was very interesting for me. Just with the NTLM hash, nothing else, but just use the username to be something else, and you would be fine. And I initially, of course, thought that, and I'm not making this up. When I submitted slides for Black Hat, this is exactly what I wrote there. I hope this is a misconfiguration in MATLAB, because I couldn't fathom that this could be possible. But later on, it turns out that this is true. I mean, and this is true up to 1.8 as well. Most of the things which we are discussing are true for a 1.8. So let me see if I have a demo of this as well. Okay, and I need to be a bit fast now. So I purged the tickets. Can I access any resource on the domain control right now? No. And the only difference in this command and the previous one is that I use a non-existent username. So the username here is non-existent. And I can once again access resources, that is, persistence is still there. So very interesting. In 1.8, ATA 1.8 specifically, it was introduced, or a feature was introduced for detection based on the ticket lifetime. And I read it from the release notes. If a Kerberos ticket is used for more than the allowed lifetime, ATA will detect as a suspicious activity. Obviously, it blunts the attack, You cannot simply create a golden ticket and take it with your home, come back 6 months later and use it. That sort of careless attacks are not possible, but keep this in mind. So there are two ways around it. First one, it is the Kirby TGT hash and not your ticket saved to the file, which provides you persistence. So stop doing something like this where you create a golden ticket, save it to the file and use it later on. That would be a dead giveaway. Why? Because of this thing. If you see, whenever you create a golden ticket, there is a lifetime attached to it, or for that matter, any TGT, there is a lifetime attached to it. If you create it today and use it 6 months later, the detection would be quite obvious. And almost all of the domains have a lifetime on a ticket, and if you use a ticket which is off its lifetime, that's a dead giveaway. So don't save your tickets onto the disk, otherwise this is how lifetime based detection looks like. A ticket was used, so allowed maximum in my domain for testing is 1 hour, and there was a ticket used for 275 hours. Now keep the ticket lifetime in mind. If you don't know it, it's in the wiki of the Mimikatz. You can actually set a lifetime of a golden ticket while creating it. So keep that in mind as well. You can use start offset and add in options to set lifetime of a ticket. And never leave your golden ticket in memory. Purge it. As soon as you are done with the things, purge it. Otherwise the detection which I showed you just now would be there ready to catch you. Now there are some interesting attacks like constrained delegation, where you have the ability to access any service, to access a particular service by impersonating any user. So there is no demonstration unfortunately for that. It doesn't get detected. Why? Service accounts support only RC4 encryption, and this I learned while discussing my talk with the ATA team. I didn't knew that in advance. Service accounts support only RC4 encryption. When you use NTLM hash of a service account to exploit or to abuse constrained delegation, it's still the same thing. There is no downgrade, so therefore there is no detection. Once again, if you run DC sync sort of attack using constrained delegation, you will still get detected. DC sync's detection, as far as I know, it's been rock solid. Couldn't find anything really interesting when it comes to DC sync. Just one thing, and this when I was discussing this thing during my training the last day, some of my students or attendees did not agree. For them, the first part, the second part. Even if you run DC sync from a domain admin of a child domain, for them it was getting detected. For me, it was not. So nevertheless, let's have a look at a couple of attacks across trusts which doesn't get detected. One is the well-known, detailed here, the well-known one, where you get access to as a domain administrator in a child domain, and you escalate your privileges to enterprise admin. There is no detection at all. Why? Because that interrealm TGT is still using RC4 hash. So no detection. If you run a replication or a DC sync from a child domain controller, during my testing, that was not detected. Right? So that is the only DC sync bypass or avoidance I know of. Now next, plain text passwords. You can extract plain text passwords using variety of ways. There are so many instances where you can get your hands on. In those cases, anomaly based detections are of no use. If you can't bypass it, just avoid it. How do you avoid ATA? By not talking to the domain controller. Like attacks like Silver Ticket. Let's say you target a server which has a SQL server running on it. You target the service account of that particular SQL server, get access to it. In attacks like these, because there is no communication to the DC, there is no detection, right? Kerberos attack, minimal interaction with the DC, you just request a valid TGS, save it to the disk, crack it offline, no detection. Variants of Kerberos, you request, if you go back here, save ASRAP to the disk, save ASRAP to the disk, brute force it offline, no detection. Force set SPN on a user, request TGS, save it to the disk, brute force offline, no detection. Why? Because we are not even talking to the domain controller, or if there is any talking, it's just requesting a Kerberos ticket. SQL servers, attack a SQL server, move across the database layer, and ATA is not even designed to catch these sort of attacks. So, of course, no detection. If it is not really looking at the traffic, there can't be any detection, right? Couple of attack chains, which I think I should skip right now because I have a couple of interesting things and I have like 7 or 8 minutes left. Or let me quickly go through this. It's SPN scanning for SQL servers, gain access to a SQL server by brute forcing the SA account or SQL injection or whatever you want. Move around in the database layers by exploiting linked databases. And then later on, if your goal of your assessment is domain admin privileges, go for it. Okay, let me skip the attack chain 2. Limitations. LDAP-S, IPsec ESP, these are 2 protocols which are documented that ATA can't have a look at. There are only certain protocols which ATA look at. If there is no detection, there is no anomaly signature of an attack, it won't get detected. Something which someone blogged about at Medium and then reblogged it, this attack doesn't get detected as well. Now, if we want to attack the deployment of ATA, that is, it is fine as long as we can bypass or avoid it. What are our options if you'd like to directly heads-on target ATA? First, you can identify ATA by simple banner grabbing, which is fine. Now, ATA subscribes to that theory that if you have administrative access on a box, it's game over. What does that mean? If you have, so ATA, if you remember, the diagram has a system part and a console part. So the console is where you, the console is on the system. So the ATA system is that box where ATA pulls all the traffic and whatever and do all its magic. So if you have admin access on that box, all the local administrator users of that box have access to ATA console. What does that mean? If you have deployed ATA as part of your domain and the ATA system is also part of your domain and you get your hands onto a domain administrator, it would be possible for you to access ATA console. What is ATA console? This thing. This is ATA console. You can access it using any such user. Which is okay. That's just using authentication for something else. Now the backend MongoDB which ATA uses to store things has no password, although it listens only on the local loopback. But once again, if you have access to the box, there are so many things you can do. You can read users' profiles, how ATA is detecting things, what it is storing, and you can do something like this. If there is an alert, you can actually change the identity on that alert, right? So here it was OPS terminal SE term admin user which was doing interesting things. Then we changed it and you can blame it on someone else. Even easier is to set the visibility of alerts. You can just change is visible to false and an alert would be gone from the console without leaving any trace. So what are the defenses against the evasions? Of course, as soon as fixes are there, upgrade your ATA. And the normal ones, the run-of-the-mill defenses do not allow your domain admins to log into whatever box they wish to, or possible architectural changes suggested here, securing privileged access. How do you avoid ATA even when it is updated later on? Avoid the temptation of escalating to domain admin privileges without understanding Active Directory environment. There are so many breadcrumbs and honey tokens and honey users out there that going at the very first moment for the lowest hanging fruit should not be there. As soon as you spot that, okay, in my very first enumeration, I found out a box where I'm a local admin and a domain admin is logged in there, that could be a deception. So be mindful of that and reduce communication to the DC. Please do not create a golden ticket just so that you can write about that in your report, that look how badly screwed your environment is, I got a golden ticket. No, not for that. If you actually want to persist, your terms of engagement say that, only then go for it. So limitations of this research or talk has been focused only on the bypasses for anomaly-based detections. Of course, there are so many of these things which may get detected in an actual environment when user behavioral detection is implemented. Couldn't test that though. In case you are getting detected, use avoidance techniques. And a big thanks to the ATA team. I know some of you guys are here. So it was fantastic to work with them. I would quickly like to say this out. I worked with MSRC last year as well while speaking about MZ. It's a new Microsoft, so they actually encourage you to go after their products. As far as that is what my experience has been, go after their products and find the right guy, and they will actually appreciate your work. So to sum it up, it is possible to bypass detections by ATA by modifying well-known attacks a little bit so that they appear normal to the detection sensors. Modification of attack methodology and staying focused on goals of your assessment, that is not talking to the DC unnecessarily, is effective. And despite its limitations, ATA still provides interesting insight to your Active Directory environment, so maybe still keep using it. And that is all. Once again, you can follow me on Twitter here. I would love that. Drop me email either on my personal ID or on my company ID for if you want to hire me. And all the slides, blogs, etc. would be available on my blog and on my GitHub. Thank you very much.